which is, I will say this, the free response questions that I picked out for y'all are directly based on binomial and geometric distributions that we are studying. So it is designed to help you study and prepare. A handful of us, by the way, can I see this real quick, did not get any kind of fair models back because I never got fair models from you. I need these. You know that when we have a demonstrated understanding, there's fair models that go with those concepts that are designed to help you study. One thing I will say, looking at fair models, and yeah, so Michael, I didn't look at the binomial and geometric yet because I didn't need that yet. Please notice I've started circling parts that say add this. I need y'all to, at some point, go back and add that information so that you have it to study for your AP exam. So that's why I started circling and starring those things. One thing I will note is you don't have to do this. Actually, I would ask you to do this. If you've noticed, recently I started identifying the page numbers that go with each of those sections. Apparently I forgot to do it on yours. I thought I did it. I did not. But
It's over here.
yeah. So I only did it on that one. I forgot to do it on this one.
Because
Yeah.
I did one last.
Oh yeah, you
Yeah.
did it on this one too.
Yeah. So well, and it's not just that. I made those page number references so that when you go back to study it later, hopefully, if you need to say, oh, I need to go back to see what it says in the book, you have a quick reference to what pages it is in the book. That's why I did it that way.
I like the pennies numbers.
I like the orange,
Yeah,
yeah.
the orange is good.
Fun fact, it's not orange. It's
Red.
this pink.
I like it. You should use that forever.
Yeah, it looks
All right.
good. I like
Well, today we are knocking out binomial distributions. We're going to get to geometric distributions. And so we actually started this a little bit yesterday. Foundation-wise, we are actually, and I should have made this clear yesterday, when we talk about the number of wins, or not number of wins, the number of ways to make the penalty kick, you can make 0, you can make 1, you can make 2, you can make 3, you can make 4. And so we're in this idea of binomial distributions, but would that also be considered discrete or continuous?
Wait, can you say it first?
So we started looking at those penalty kicks yesterday, right? They could make 0, they could make 1, they could make 2, they could make 3. So would that be a discrete or continuous? That's a discrete. So when we talk about binomial random variables, what I want you to hear me on is a binomial random variable is just a special type of discrete random variable. So understand there are special types of discrete random variables that we study, and that's what we're about to focus on. That's why it's here inside the target section. Our binomial random variables are a special type of discrete. We will really knock out. Nope. There we go. Calculate and interpret the probability of a binomial distribution in context. And calculate and interpret the mean and standard deviation of a binomial random variable in context. That does remind me, do please look at your demonstrated understandings. Across the board, that's probably one of the strongest demonstrated understandings that I've had. So I don't know for you, sorry. But I gave y'all I did not give y'all all the multiple choice. I just gave you the free response answers that I did and the corrections to the false question or false statements that I did, so that you have a reference to in the future. The vast majority of us crushed it on the multiple choice on that second page. That's why I did not put that in there. If you need that or want to sit down and talk about it some more, please do that. But we got to go. All right, so we looked at this yesterday. Will the U.S. win the World Cup? And so we looked at this idea. They felt like they needed to make at least 4, I think, of the penalty kicks. And so we looked at the probability of making all 5. And so what was the probability of making the first one?
0.7.
0.7. The second one?
0.7.
Third?
0.7.
0.7.
And so it was repeatedly multiplied by 0.7. So we did the 0.7 raised to the 5th. Now that's the probability of making all 5 penalty kicks. Then we got down to here and we said, hey, they could make only 4 of them, so they make the first 4 and miss the 5th. So it's 0.7, 0.7, 0.7, 0.7, and then 0.3. Now notice that is assuming that these probabilities or these events are what? Independent, right? These are independent events. So do you need to come back in, Chris? A new bag? Thanks, sir. So right here, we wrote it as 0.7 to the fourth times 0.3 to the first. But was this the only way to get 4 makes?
No.
No, we talked about it like they could make 3, miss the fourth, make the fifth. They could make 2, miss the third, then make the last 2, right? So there's lots of different ways. And Braden, you're like, man, it'd be nice if there was a way to quickly find out how many they have, right?
Yeah.
How many different ways it could happen. And so what did we look at? It ended up being 5.
Yeah.
But how did we find out how many ways it could happen?
N over R.
And be careful. So the way that you would read this, and I did notice the way Mathematic does it is this. And so it's the same thing. The C stands for choose. So it's N, choose R is the way you would read this. And what that means is, this is how many objects, in this case trials there are. R is the number of slots, or in the case of what we're dealing with, trials of success. Slots or successes.
So it'd be like P,
Not P, because what is P?
probability.
Probability of success, right? So in this case, how many trials are we running with? 5. How many successes did we want? 4. So it's 5, choose 4. And I meant to pull up the formula for this, or the AP formula sheet. Does someone have that in front of them? Can I see this real quick? Too good. Yeah, so I can show you what this formula, what this actually means, but you don't need that for the AP exam. All you need to do is actually just substitute into that, and then you can use the calculator. So do y'all remember where I showed you can find this?
Binomial PDF.
Yeah, so if you go, well, so we'll go there in a second, but if you go to menu, then probability, under probability, number 3 says combinations.
Okay.
Right,
And
so
then NCR.
NCR, so that's this, right?
Yeah.
And that's just if I want the number of ways I can get that many successes. Okay, so that's just if I want the number of ways that I can get that many successes. NCR, in choose R. Now, instead of though, so remember what we said then is 5 choose 4 times how many, what's the probability of success?
It was
0.7.
0.7. And then how many successes did we want?
4.
Times, what's probability of failure?
0.3.
And that would be to the first. And so we're gonna,
Just do 5 times that? Or like-
you could, so yeah, you could do, but so remember that would be 5. And then you just multiply, because remember what we said is we'd have to add all of those probabilities, but they'd be the same. But do remember, you might need to plug into the formula, but I feel like there was an easier way than even that.
Binomial PDF.
So that's where we could go to the binomial PDF. So go back to menu, open up a calculator page.
Statistics, distributions, and binomial.
So remember menu, statistics, or probability, either one. Then you go to distributions, and you just need to remember it's going to be down here towards the bottom, right? We're looking at binomial PDF. Number of trials was how many?
5.
5. How many probability of success?
4.
Probability of success?
0.7.
0.7. The number of values of successes that we want.
4.
And enter, right? So there's that probability, which is exactly what we got when we multiplied all that out, right? 5 times 0.7 to the fourth times 0.3. So that is the quick way to knock this out using the calculator. Now the last thing to remember is this. Part E, overall, what is the probability that the team will score on exact, oh no, we already did E. We wanted, number 3 is what I was going to talk about. So right here, so what is this, let's break down these numbers. What is this 5 again?
Number of trials.
Not this 5.
Number of ways.
So number of ways,
The
Combination.
yeah, it's the combination. So number of ways to get
4 successes,
Four
1
wins
miss.
and 1 loss.
4 kicks.
And so be careful and go back to your context. Remember, it was 4 penalty kicks, right, that they made. So 4 successes, penalty kicks, PK goals, on how many attempts? 5 attempts. Alright, so that's what that 5 is, that's where that combination is. That's the number of ways to get that many successes on this many attempts. What is this 0.7 then?
It's a win.
So
Chance of making a penalty kick.
I would say be careful again. It is probability of success. So in this case, probability of making a penalty kick. And so what was this 0.3?
Probability of missing a
So
penalty
probability of missing the penalty kick, so probability of failure. What's this 4 that's on above the 0.7?
Number of goals.
So number
kick.
of
Success.
successes or goals in this case. And this 1 right here,
Number of failures.
number of failures or
misses.
misses. All right. So, if a World Cup game ends in a shootout, what is the probability that the U.S. team wins? How are we going to find that as a throwback?
You do the,
Add the probability of making 4 and add the probability of making 5.
So, there's a couple different ways. So, could I take the probability of making 4 and add it to the probability of making 5?
well, you take the probability of making 4, then you multiply it by 5, then you add it to the probability of making 5. No?
Why would you multiply it?
Yeah.
Because there's like 5 chances to do it.
So, there's the probability that
What am I
x
talking
is
about?
greater than or equal to 4, right?
Yeah.
Which would be the probability that x equals,
5. Right now.
that's one option,
4 or 5.
or x equals 5. Do I need to multiply anything if it's that union?
I don't know. We were doing this
You just
yesterday.
add, right?
We would just add, I will point out, these 2 events are what, Braden?
Or no, disjoint.
They're disjoint. You can't make 4 and make 5 at the same time. So I would just add those 2 probabilities. Alright. So, I don't remember what those probabilities are. What would it have been? The 0.1681, is that what that is?
Yeah.
Plus the 0.36 something. So add those probabilities together, what do we get?
Zero point 52825.
Y'all good with that? 0.52825, is that what you said?
What?
I can't read my handwriting.
Okay.
For the first
What did y'all get?
463.
You got what?
0.5463.
5463?
So wait, is the probability of make all 5, what was it? Is it 0.16 or 0.18?
1681. So yeah, 16 or 17.
I should probably write down numbers.
Am I crazy?
Okay. Real quick note, I will point this out. PDF stands for a probability density function, okay? Probability density function just gives you a probability at a single value, right? Does anyone know of something that might give us probability of more than one value? So I'm going to go to distributions again. Look under binary.
CDF?
Yeah, CDF. You know what that C stands for?
Cumulative.
Cumulative distribution function is actually what it is, so that D changes, but cumulative. Notice in this case, how many trials do we have? 5. What's the probability of success? 0.7. What's the lower bound number of successes we want?
4.
And what was the upper bound?
5. I would
I was
have
right.
a 6.
0.52822. Someone lied to us.
I didn't lie.
Hey!
What's up?
I put 6 successes and it still gave me a number. It doesn't work.
I
What?
got
I
that
put
one.
5 trials and with 6
Did it
successes.
give you that same number? It shouldn't have.
Yeah, it did.
Okay, so then well, here's the thing, what's the probability of getting 6?
Like maybe this is a route.
Successes.
Well, I guess, yeah, I guess.
It's 0.
Yeah, I guess.
So, yeah, It should have broken the calculator, I would have thought,
Yeah,
but
that's what I thought.
Yeah.
too.
That's just the
Oh, okay.
binomial PDF plus the 0.1618.
which is also a binomial
I
PDF.
didn't show it.
Right, my point is the CDF goes ahead and adds it up for us.
This is
Magic, I know. So, here's the thing. You need to be able to plug into the formula for the AP exam, and you have to be able to recognize a binomial situation, but the calculator does the work for us. Let me say that one more time. You need to be able to recognize a binomial situation, you need to be able to plug it into the formula, but again, just let the calculator do the work. Okay? So, write down what notes you need to on those details, and then we're going to go to the quick notes on the back. Or you could write it down, Sanaya.
I ain't writing it down.
Oh.
It's the
Can you
angle.
really not see from there?
No, I can, it's just the angle I'm at, I would have to keep doing this in Monday, yeah. At least I'm writing it.
Did you guys know that today is election day for the
I had heard that.
Tuscaloosa mayoral and city council race? You
Who's
know?
winning?
Who's 18?
I don't know, I just got a text message from
Yeah, I got a sketchy text about it too.
Lauren with black photos.
Did you get that
and
toll
ads.
text?
Yeah.
Oh,
should
should I go vote?
People trying to
That's all
scam me.
go vote.
Should I go
Alright.
what? Alright, no, guys, we got
Too late
stats
to
here, let's go.
You're not
Let's
all
go.
participate.
Contrary to
in
popular
democracy.
belief for some people, when my stats class starts, the world does stop and we pay attention to stats. What?
You've been messy all day. I told him, Mr. Kenny, you can't expect me to only have your work to do. I said, just because stats
I do
starts, the
expect
world
you
doesn't
to
stop.
be here during this class though.
Robertson said.
It was
Robertson
one
said-
time that I
Robertson-
really wasn't here.
Robertson
That
said
was
just
my
not show
fault.
up on Friday to the presentations. She was like, Hinton said not to be here.
You can take a 0.
Oh.
Okay,
Oh,
so,
that's
number 1, so first things first, to recognize a binomial,
What is ultimate goal? Yeah,
learning target, number 1.
thank you. Do we need to work on
No. To recognize a binomial distribution, you need to know bins.
Bins.
Yep,
I thought you said bins.
Like
bins,
Mercedes.
okay.
Yeah.
The I there,
Wait,
each
can you
of, huh?
Can you guess each letter?
Yes,
Binomial.
Bye there.
super close. No, it's close-ish.
Bicycle.
Wait, one letter.
Yeah,
Bisect.
who's a sheep?
Bins.
Bin.
Oh.
Binary.
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 Oh, 2.
Either
Why would I say
there,
binomial?
either you have a,
0.
0, 1.
0, 1, 0, 1.
Success or
1,
failure?
Yeah.
success or failure.
It's true or false.
AP Cal coming back.
Okay, so success
I don't wanna
or
think about
failure,
binary.
that's binary, right? Either that you have a success or you have a failure. If it's not binary, it's not binomial. Any guesses on the I?
Integer.
Independent.
Those events have to be
Independent.
independent.
You
I
also
is a
said
I,
so,
but
it's just repeating.
they have to be independent events.
Decent line.
Meaning that the outcome of one does not affect the outcome of the next, right?
What is on for this?
Sorry, people.
What does that N stand for? Any guesses?
Numbers.
It is actually number.
Number
No,
of
numerals.
trials.
The number of trials
Successes.
In total.
is fixed. It is set. So in this case, how many trials did we have? How many
5.
kicks? There were 5, right? It has to be a set number of trials. That is in contrast to the other distribution that we'll study later.
Oh, okay, I was gonna say.
Okay? So the number of trials has to be fixed, and the S is going to be a little bit of a stretch for us to see right away. Any guesses?
Statistics.
Wait.
Hey, stop
Same,
it.
Same
Same
size.
chance of success.
So same probability of success.
How'd you get that? What the freak?
Well, if you go back and you look at the formula and look at what we did, it had to be the same probability of success every time, right? So those are the 4 checks to recognize a binomial distribution. If one of those is not true, it is not going to be binomial. But if all 4 of those things are true, so remember your bins, that's what you got to check for binomial. If it satisfies bins, then it's a binomial distribution. Okay? Now, the second part of the binomial or the learning targets here is the formula. So, I need us to remember this. Why in the world am I doing a big X here and a little x here?
Uppercase, lowercase.
So, but what's the uppercase stand for?
Population and sample?
This is my
Random variable.
random variable.
Oh.
Lowercase is the
Value.
value, okay? So you could also use, I think a K is pretty common. What's the formula
Dominant
sheet have?
recessive?
No, it has X. That's why I use that X there.
Too much
So-
bio, too much bio.
Dominant recessive.
So this value in this case would be my number of
Trial.
Success.
successes. Right? So what we're doing is a binomial random variable. We want to know what is the random variable going to equal this? What's that probability? So how's this formula going to work?
N over R, or is that just combination?
N choose R. That's part of it, right?
Oh.
Where the N is my
Trials.
number of trials, which really I shouldn't use R here. What letters should I use?
Okay.
X.
Wait, little x or big x?
Well, is it a random variable? Is it a value?
Value?
It's a value, so we use a little x there. Get a question. Okay, so N is my number of trials, X is my number of successes.
You said good question.
Yep, you can get a piece of candy for sure.
I can.
Okay, times. Think about that formula that, or what we ended up doing on the previous page.
Percentage of success.
So, not
I went
percentage.
straight to that paper.
Chance.
Probability.
Probability of success, right? So chance or probability, but we use P there. Now, remember, every success has that same probability, right? So P raised to what power?
How many?
To
the
X?
By the X.
Raised
Oh,
to X. So remember that P is my probability of success,
And that's why it's raised to the x, because it's the number of
because that's my
successes.
number of successes.
Mhm.
Now, what am I gonna put next for my, what's gonna go next?
Times percentage of loss.
So that's your failures.
So probability of failures, of loss.
What's the
But-
equation
Of C
for?
complement or?
Well, what's a way that we could write P complement
How is
if
this
I already
on
know
the
what P
One
is?
P.
How are P complement and P
One
related?
minus P.
Ah, the P complement would just be 1 minus,
Oh my
The
God.
P,
Yay.
so 1 minus P is my probability of
failure.
failure.
What would be X?
1 minus X? Or-
Not 1 minus X. Think about, or this is my number of trials.
N minus X?
There you go. If that's my number of trials and I take away successes, what am I left with?
Failure.
Failures.
What is this over here?
So N minus X is my number of failures. By the way, I know like y'all are all like trying to figure this out, but does anyone know what you could have looked at? I don't know.
The formula sheet.
Reagent or-
Oh my gosh, that formula sheet. What does it look like on the formula sheet there? Michael's trying to look under Serena's.
Probably the same.
Does it say exactly the same thing?
Wait, so is the n that's in the superscript, is that the same as the n?
It's the number of trials.
Yeah, okay.
Because think about it, if you, let's say, remember in the 5 kicks on the goal,
Yeah,
we take away the 4 successes.
and then you get one.
You
Yeah,
get
okay.
left with 1, right? So if you take your number of trials, take away your successes,
Yeah.
you're left with your failures. Yes, ma'am?
So, the first P is uppercase and the second one's lowercase?
Nope, those are both lowercase.
So how do you know which one's success or failure? You just
They're
know-
both success.
This is failure.
Because if you take 1,
Oh,
you
the
subtract
equation,
away the
The
success.
parentheses is,
Yeah.
okay, I understand.
Yeah. Yeah, that's why I put the brackets kind of underneath. So yes, that's a good question for sure. Be careful, that P is the probability of
You
success.
said it's a good
Not that
question.
level of good question.
Dang.
Alright.
Big back
That's
pass.
1
Yeah, ain't nothing
minus
wrong with
the
that.
probability of success. Okay. What are your questions about this?
Oh, the way
Why are you
everyone has
taking a picture
is
if it's
not
on the
a problem.
page?
Is there a formula for
It's
the,
on the page, where did you get a picture?
this, but like,
Is N minus X supposed to be X?
like, how we put it in, the binomial CDF, is there a
Yeah,
formula?
that's a
for
good
that?
question. So, what Serena's asking is, here, I'll just put it right here. Is there a formula for when it's a CDF situation? So let's say we want the probability that X is greater than or equal to, we'll stick with that lowercase x. What we will do, let's say X sub 2. we would do n choose x sub 2 times p to the x sub 2 times 1 minus p to the n minus x sub 2.
So do we have to write this down?
Heck no. Well, ish. Hold on a second. Plus n choose x sub 3
Oh my god.
times p
That's too much.
to the. Hold up. Hold up.
He's gonna explain, he's gonna
Probably gonna have
He's
like
gonna
a
play
sigma.
Or we can just do
He's
some.
gonna like do a sigma thing and then
Yeah,
it's
he's
like
gonna do a little
show.
something.
Yeah,
Just keep
good
it going.
question, by the way.
Plus dot. Okay, so notice substitute it in twice, and then put plus dot, then jump to the calculator and do CDF.
Sigma.
So how much is that?
That's
But this isn't on the formula sheet.
So, for example,
That's not on the formula sheet.
okay, but hold on a second. Think about what we just did was x was greater than or equal to 4 trials, right?
So we just make it squared?
So we would do 5 trials, choose 4, times the probability of success, which was 0.7 to the 4th, times 0.3 to the 1st, plus 5 choose 5, times 0.7 to the 5th, times 0.3 to the 0.
So, okay.
So like you would
Yeah,
just
because it's
you would do
Because it's
those
just
two
two.
situations.
Yeah, the twos,
Yeah.
the twos in the
Probably
subscript
the X
position, which
sub-
means you aren't squaring it.
Right, so
It's
what I'm
just-
saying
it's just
is
a marker.
the second number of successes, that's why I
So
say
you could
x
say,
of
you could
2,
say xi.
and then x of 3 for the third number of successes. And so you would just add those two probabilities together. But again, that's what I'm saying, you just plug it in, you put plus dot, and then you could, and I will say this, there's a way to do it with variable expressions. If you want to look at that, we can. I'm not doing that in class. But I would just put the plus dot and do normal CDF in the calculator.
Why is it
Don't
plus-
do these calculations in your hand, or by hand.
Why is it plus dot?
Well, in this case it wouldn't, but let's say it's all the way from x sub 2 to x sub 7.
Can you just do
Then it'd be
sigma?
dot, in choose x sub 7 times p to the x sub 7 plus, or times 1 minus p to the x sub 7 or n minus x sub 7.
Can you just do sigma for that?
So you can, but I'm not gonna go into how to show that for now.
I mean, can you
'Cause
just
there's-
like put it?
Because wouldn't you just do like the sigma there, and then wouldn't you do x of I?
Yeah, it just shows like.
Not
you
quite,
did
no,
every single
Because
one.
one's going up, one's going down.
Where'd you go to?
Guys, we gotta move, but,
Alright.
and y'all are getting bogged down in details that don't matter. Write this out, go to a calculator and do binomial CDF.
God.
If you wanna learn how to do sigma in this, then I'll show you separately after class. Yes, Jaden.
Is the only reason you have a whiteboard on a whiteboard so you have grid lines?
That's for my Algebra 2 class, yes. Yes, Spray.
Does the same thing work if you're like saying like from like a range, like x is smaller than 4 but larger than 1?
We're not gonna ever do that. I mean, you could, but you would just do 2 different binomial CDFs in that case.
Okay.
Alright, so I want you to take 4 minutes, talk with your small groups at your desk. I just want you to figure out whether you think A and B, or one or the other, or neither, are binomial distributions. So it's just figuring out, is this a binomial distribution?
This is binomial.
It's on the back.
Like, we'll whack it.
Like off on my hair.
Go for it.
Like right now.
80% probability of whacking one. So they're independent,
Yeah.
so it's not affected
So,
by
well,
the
no.
previous one.
That over here is this one. It's just notice I had to do it more than one
So
time.
the number of trials is fixed.
It's more than once, because it's just greater than
20.
or equal to.
Yeah, it's sometimes
But it's still
25.
using that.
Yeah.
And it's binary
also-
because you either hit or you don't.
Yeah.
Don't stress that.
Oh, yeah.
That was based on a question they
I
had.
think he said it's good. Wait.
He
We're
just
about to
says
look at
stay on
it.
the grid.
Maybe.
You need to figure out
I
if
just
it's
wanna see if
binomial.
it's a
So,
binomial.
When you do it on a vertical
Number
surface,
of
like
trials.
You
that,
can, no, you can, I'd say do it in your groups, some people will struggle with this.
Number of trials is fixed.
Yeah.
So
Okay, what are our?
Oh, you should probably write down.
Well, it has the first three.
so it's
I
20
just-
over.
Yeah.
same
Oh, wait, so
probability
should we
of
just do,
Well,
Wait, better justify it.
we just need to know if it's like binary.
And that's 16. Number of successes would be 16.
Huh?
Right.
We don't have to do anything.
Yeah,
Let's
yeah.
figure
So
out
on the,
if it's
yeah, I guess we will
So,
go
yes,
over
it
it,
is
but make sure
binary.
you can
So,
explain
wait,
why
what
this.
was that
On
last?
Are you
one?
sure?
Yeah.
the
Change
APE
probability of
exam,
success.
you have to actually go through and check it and
It
show that
means
you checked it.
like you know the conditional
Can
things
you
of
just,
like
like,
if I have like
write bids and,
the
like,
bag
check
of
off
stubbles
each
and
one?
I
No,
take
you
out
have
the
to
yellow
write it.
one, it's a smaller chance of me also getting another
Now, the
yellow
bins will
one.
help you remember
That's
what
like
the words are, but you
bins,
just-
If it's binomial, it can't be like that. It has to stay the same. So I have to put that stubbles back.
Oh, okay, okay.
Yeah, because, yeah, I was gonna say.
So
if
does
you're
that
4 out of
just
6,
kind of-
take yellow out, it's 3
Number of
out.
trials.
That just ties back to like it being independent.
Yeah,
Yeah.
yeah, that's like, it says not affected, so it's just.
Okay. So it is.
90 more seconds.
I just misspelled independent. Are you kidding me? Okay.
Peter Williams.
Why am I screaming?
I like that.
Okay. We can watch the
How does
video,
skee
too.
ball work? Is it just you shoot
Guys, how
balls
do you
till you
spell
go in?
independent? It's
The
an E,
B.
right?
No,
The B context is yes, that.
I thought ski ball.
B, you're talking about B?
What's skee ball?
Ski ball, it's where you roll it up into the thing.
Yeah.
That's what I thought.
Even I know.
But don't you have like a fixed number?
Oh, like
But look
arcade
at the
game?
phrasing of
Huh?
the question.
I know, but I thought you wanted to.
Yeah, like you roll it and it goes up into the whole. Dude, I have a little
You're
tabletop
gonna keep
version.
playing until you get one in the 100.
But why would you play, dude? You want to get the jackpot.
That game's fun.
The 100 is the
100
jackpot.
point is the
That is the
jackpot.
jackpot.
But you might as well get the jackpot several times.
Bruh.
Bro.
Y'all skee ball games are dumb.
Just letting you know it's hard. Alright, so let's talk about it. A, is this binomial?
Yeah.
Why is it binomial?
Because it has has success or failure, so it's
So it's
binary.
binary,
Each event is independent from each other.
so it is independent,
Yes, it says not affected.
The number
it
of
is not
trials is,
affected, okay?
the number of trials is fixed because there's only 20 moles
So
per round.
20 fixed trials,
And there's the same probability of success each time.
so 80% chance of success. Alright, so we have a binomial distribution. Part B, next you play skee ball. You know that you have a 10% probability of getting any given ball in the 100-point hole. Let y equal the number of balls you must roll until you get one in the 100-point hole.
It's not binary.
No.
Why is it not?
Trials.
It's not what?
There's not fixed trials.
There's indefinite.
Well, is it?
trials.
No.
Yeah,
I mean,
Yeah,
there's
there's
no
indefinite
success
trials
or
because.
failure really. Well, there is.
What's the success?
Oh, the
Make
Get into the 100
the
point.
failure's not.
Failure's not getting it there. But what was your note?
There's not fixed trials.
There's not a fixed number of trials, right?
Because you stop when you get to it.
Until you make it, right. So there's not a fixed number of trials. So no to fixed number of trials. Now, are they independent events?
Yeah.
Okay, so that would be there. Is the same probability every time?
Yeah.
So the only reason it's not binomial is because it's a no to the fixed number of trials. Okay?
Yeah.
Questions? Alright. Okay, I want you, is it just A and B? Yeah. I want you to work on A and B. Try applying what we've just done, because you're not going to have me on the AP exam, you're not going to have me on the test. I need you to think about how we're going to apply that formula here. So I'm going to give you 3 to 4 minutes to set it up. Go ahead and start talking about it. Read it.
Tsunami duck pond.
This is
You wanna get back?
Pummeled by
So wait,
tidal
you put 80% by numbers of trials?
You wanna get back?
Oh, put 80% by numbers of trials? Or was this?
No, that was the probability of success.
Anyway,
The
math
same probability of success. Say again.
Anyway, math normally uses the word tumultuous.
Exactly.
Right?
Well, because he made it.
Nerds.
I didn't make this one.
Okay, whatever. You chose it.
I did choose it. It's great.
Because you used it.
So there is replacement.
Yeah.
So there's the same probability.
Okay.
There's not two variables because you have stars. No, it is.
We'll talk about it soon, so don't forget. There's your formula. So make sure you have that written down. Right here. And
probability
then
is
label what
20.
those things are.
Point 20. Hold on.
Yeah, point.
I hate this thing. I can't just
Y'all
click
talking
on
about
buttons
this.
So
on.
you must switch your hands. What don't people ever touch you on if you play the game 10 times?
That is fixed.
Oh wait, tell
Well,
me.
we know it's a binary.
Yeah, it literally says it.
Yeah.
I just see my holy.
Okay, so the big number
Plug
of
yourself
trials
in.
is
I thought you
No.
guys just write it.
You need to look at A again.
Yeah, 10.
Yeah,
I
10.
need y'all talking about it. Yep.
It's hit.
What?
Mm-hmm.
Yeah, you
Oh.
play this game 10 times.
Mhm.
So it is binomial, so
Okay, so
it'd be.
I'm telling you it's binomial.
Okay.
That literally just says,
It
it literally says W is a binomial random variable. What's the fixed number of trials? 10. What's the probability of success?
Point 2.
Point 2.
I said 10 and then you said no.
No. Talking to him. Okay.
10 over probability of 6. Wait.
Wait, when do you win if you get a
Star.
star? Okay.
So, point
Wait.
2.
So we can't do
What's
N over
S
R
star?
or
Why not?
NCR.
Why not?
We have to. Would you just take
What's the N stand for?
number of ways?
No, that is not what N stands for.
No, number of successes.
Number.
So it's
Oh.
10.
Oh my god.
Did you not write it up there at the top?
Number of trials.
No, N means number of trials.
Right.
X means number of successes.
Right.
Yeah.
Okay.
Times
Huh?
probability of
You're done with A. You're on B, dude.
Oh my god, it's like speaking.
I did.
Oh,
I didn't write it down.
Dude, A just says what's the fixed number of trials. Guys, A just says what is the fixed number of trials. What is the fixed number of trials? 10. What's the probability of success?
Point 20.
Point 2. Move on to B.
Oh my god.
So if it tells you what's the point of the question?
Fixed number of trials. 10. Probability of success.
Oh, yeah.
Or just P. You don't need to say P of S. P is 0.2.
Okay.
Move on to B.
Say
Say again.
Exactly 3 times, show your work.
What is
Okay.
it?
3
Look at the information.
equal.
Look at what A says.
So hash.
Your what, son?
0.2 to the power
Hey guys, there's a formula.
Yeah.
Please use that formula.
0.2
Something like that.
to
And then it'll be
the power
times
Why
0.76.
so low?
2 minus 3.
All that calculated.
What
Yeah.
is it? 3
Am I
from?
crazy?
Is it crazy?
We're going
The 3.
But it's
Write your chances.
It's just show your work so you can just
What?
later.
Is the chance of this
Isn't this a binomial?
What's only asking?
Yeah.
Yeah.
Number of trials.
And how many trials?
Exactly.
Oh, wait.
Probability of
Is it-
success.
is it-
0.2.
Yeah.
It is no, it's
Seven
PDF.
for the-
It can't be CDF because we don't have
No,
a
no,
assignment
no,
journal.
it's not a fraction.
Yeah.
So it's no trials.
So, two things. One,
Yes, it is 10
10
trials.
trials. Probably
put a
success
fraction mark in
0.2. X
second,
minus
why are you
Don't
doing
make
that?
me read it 3 seconds.
Point.
0.20122.
So this is how many times you win, right?
0.2.
this is a what?
Or
This is
sorry, this is a chance of winning, right?
Binomial.
Statistic.
PDF.
Yeah.
And you, and it's asking how many times.
Because
it says-
if you go to binomial,
Wait,
I'll
wait,
click on binomial
It's not a
CDF.
fraction.
Now pull up.
It has a low amount of
Never seen you
numbers.
put a
Okay,
fraction
okay,
mark.
after that,
Choose a chance
after
of
that,
winning.
this is
Because
correct.
PDFs
That's
for both
23 times,
Yeah,
right?
that is
That's
correct.
correct.
That's
Bruh.
For normal CDF or normal PDF, it's 1 point. For normal PDF, it's 1 point. Normal CDF, it's
You talking about the one that does first when
You win if there's stars in the bottom, right?
Or statistics.
And it says show our work.
Okay, so 20 is the
So it kind of
Because we just wrap the formula.
And then the 3.
No, that's calculator speaking. Don't do that.
Well, I mean,
No. This, look.
The number.
I mean, you kind of
This
wrote it.
guy.
Yeah, you just plug it in.
This is your chance of winning.
So type
This is
your
how many
2.
times you
I
have
don't
to
want to write all
win.
our stuff.
Oh, and it's the
How
opposite.
many-
Yeah, this is how many times you fail, and you have to fail exactly.
Because I
the
said it
same
could
time.
be equals.
Yeah.
Okay, question.
I
Yes.
just did.
Is this like enough work? Oh, she look,
No,
I wrote the formula but filled it in. And then put equals and then put the answer.
I think that should be good.
Yeah.
7. No, that's 3.
That's good.
So that's exactly what I would write.
W.
Okay.
You can do the 1 minus 0.2 if you want.
Do you have to have the P equals W equals 3?
So what I will say is this, I would highly recommend this because what are we doing? We are looking at what random variable,
W.
W, and we want that random variable to equal
3, so you should write it, okay.
I would write that probability notation. I need y'all to be careful about this because a couple people already made this mistake. Have you ever seen me put a fraction bar here?
No.
No, it's not a fraction, it's a, I know, it's a combination.
It's hard not to.
I know, but you gotta break yourself. Listen, I'm not getting on to anyone, I'm just gently correcting for the future because I've done it in the past too. Alright, so what is this probability?
0.201.327.
Wait, 201?
What are you guys talking about?
Mr.
0.
Kenny.
Mr. King.
Yeah, it was 201.
Yes,
Oh,
201.
327.
Alright, 4 decimal places is perfect. I thought I saw 0.3 earlier, not 0.2 in here. Yeah, just put that in the calculator. Jaden's doing it by hand. I know what he's doing. If he wants to do that, that's fine. Jaden, don't waste that time on the AP exam
Wait,
though.
hold all the class.
So,
There's a
Jaden-
calculator does it in 5 seconds.
Well, yeah. Jaden is trying to prove that he knows what combination is and what the formula for that is, but you don't need to know that for this class. Alright. So, questions about how to use,
Save that
how to
energy for
recognize
right.
binomial PDF. Oh yeah, y'all are leaving, aren't you?
Yeah.
Ooh.
We can watch the video.
Yeah, you're gonna need to for what we're about to
No,
do.
sorry, can we see like what notes this
It's
is?
a-
So, I'll go ahead and, so one, we are, here, you can get the next set. I already gave you the next set that we're about to do, but this is what we're about to get to after that. You need to watch the part about geometric distributions. Is it just you two?
Yeah.
Not Jaden?
Oh,
Alright,
boo.
cool. Did you say all boo?
What? Who said
What?
that?
Alright, guys, we're gonna keep going. So,
Please stop.
what we are now gonna
Taking your
do
name
is
off the
actually
project.
get a little bit more practice with binomial. Binomial shows up regularly on the AP exam, so we're gonna get some more information about the binomial random variables right now. So, this is the pop quiz thing that I passed out earlier. It's time for a pop quiz. We hope you're ready. The quiz consists of 5 multiple choice questions. Each question has 4 answer choices labeled A through D. Now for the bad news, you will not get to see the questions. Make your best guess, like getting off our phones. So number 1, bubble in an answer for each question for the pop quiz. So,
You mean
I'm being messy?
that's you? I
Oh.
told you.
I was gonna say, you get on your phone. So let's, I want you to answer what numbers 1 through,
See, now if you bust your
Hey.
tail, I'm gonna let him.
so go ahead and work, how about this, I want y'all to work together, I wanna give you some time to think on these things, and we will come back together in a second.
What happened to my things?
Oh god.
Where did they go?
Yes.
Where did they go?
So just make your best guess. So, yeah, just kind of make it,
This is his.
yes. You have your ABCD up there at the top right.
No,
Okay.
it's not possible.
Yeah, just bubble in. Okay.
People's soul praise.
His what?
His wolf.
Did he act? It's not. It's not.
He sold his what?
It's for his wolf on accident.
What?
Well, maybe he just lost it.
No.
What-
No, I think he's talking about this.
No, it
The
wouldn't
pop
be,
was,
right?
it was with my grades too.
Well, actually,
And this is Pierce.
no,
Well,
it is.
That's
one.
no
we'll figure it out. Hey guys,
It's the same
look at what
class.
Sprig has, we'll go over it in a second.
Okay.
Okay,
Question.
alright, I'm gonna give you the answers for numbers 1 through 5 at the top there.
Wait.
You ready?
No.
No, that was way too fast.
Okay, not numbers 1 through 5, the multiple choice, the bubble
Oh,
in,
okay.
numbers 1 through
Oh, I
5,
wasn't ready.
so that you can identify how many you got correct. Alright, number 1 is C, number 2 is B, number 3 is C, number 4 is D, and number 5 is A.
Okay, I
I
got
got
two and
one
two and five.
Okay, so 2 out of 5.
Go again?
I got one.
I said number 1 was C, number 2 is B, number 3 is C, number 4 is D, number 5 is A.
I got the last two right.
Nice. You know what's impressive
I think
is?
that's
I just made all those up,
Wasn't
and I remember
It's
the second
2C?
time around.
Are you
C,
so
B.
serious?
Yes, it's illustrating a point. Get off me. All right. C, B, C, D, A. C, B, C, D, A.
I got one.
Write down how many you got right.
We got one right.
You're so quiet today. What's
So, I now need y'all to actually work on numbers 2 through 8.
Okay.
Give me a
so
break.
Actually, 2 through 4. We'll talk about number 5 in a second.
It is a binomial setting.
Actually, you
so
can
you
do
can either
5
have
and
a
6.
success
I
or
thought
fail. What's
the
the V?
Okay, so it has the same chance, like probability of,
The events or independent.
but the probability of getting
Okay, so stop.
like
I just wanna-
success is
where you
the
from?
same, and there's five.
So one thing I will say,
I don't
suggest
like you
is,
over me.
I'm
It's
just-
not bad.
Okay,
Okay, no, but I don't like.
I would highly recommend reading this out and going step by step.
I might have feels from
That's how you check to see if it's binomial, right?
Uh-huh.
Okay, so let's go.
Okay, what makes it?
Trying to
We'll
find
add
it.
context to it.
Trying to text Peter.
I don't know. I don't think I have his. No, I don't have his phone number. He's not invalid. Sorry, I'd like to. Serena says but she's not.
It's either you have
Oh, Michael.
success or.
Oh, no, okay.
Michael, do you have Peter's phone number?
Okay.
Can you call Peter and ask him to bring Raven back to school?
Or
Yeah, that's what-
Because
Well,
he's
probability,
this is
Peter's, right?
That's nobody's.
Nobody. Don't call me, because how do I know how to work?
Wait, so Joey called her.
Where would it
If
be?
it looks like they're
That's
done
the
with
question.
it, yes.
Alright.
Just text him, don't call me.
Or like which question?
Lay it on
looks like they're done with? Yeah.
Ask him if he has my
I feel like he's not gonna see. I'm gonna see.
Oh my
Yeah, you can
god.
call him.
Yeah.
Okay.
For the probability of
That's so
success, do you want us to use the letters you gave us, or do you want us to use just like 1 in 4 for each of them?
What do you mean?
Like probability of success?
Well, the probability of success is 1 in 4.
Okay.
What you want
Okay, don't worry about
for?
Trying to get in touch with Peter.
Yes.
Oh.
Did you leave something?
So funny.
I'll see him tomorrow.
It sounded so ominous.
Alright. Okay, so.
And the number of trials is fixed at.
much right.
Fuck.
Yeah, I just wrote what you said. 'cause that's
Calculate
all
the
I
probability of
wrote.
getting
Also,
Yeah.
I'm not putting grades on them.
Yeah.
What's the content that
Just notes.
and then just scans and then so we can get them back and then just
Yeah. And grades
So
later.
the probability of
Yeah, it's 1 out of 5, right?
x equals 2. Exactly 2.
For
so-
what?
Be number of trials of 5 over probability.
Mr. Kenny, you know what's so funny?
Sorry,
one
I
out
thought there
of
was
five.
I got
5.
exactly 2 correct, so is the probability here the same probability?
0.2.
What's the probability of getting
No.
a
Wait.
question right?
2 to 2.
It's equal to
25, no.
5.
1 out of 4. 25%.
How have you been
That's,
doing
but
this?
1 out of 5 would be 20%.
Erase that.
This makes me
Right?
happy.
There's not 5 answer
Writing
choices.
this makes me happy, okay?
No, there's not.
Am I? Oh, there's
Writing this
20
makes
answer
me
choices.
happy. It makes
No.
me
What?
understand what's going
Each question has how many answer choices?
4.
So the probability of success is
8.
1 out of
4.
4.
So it'll be 25.
There's 5 questions, 5 trials.
So you have to roll.
Can you show me how to do that?
Are you saying
Because I was
these
kind of
things?
confused with the DYU, how to basically
No.
like.
It's
add them
wrong.
all
I just
up
do
and
this,
add them all-
okay?
add
I
them all
don't know
up
why.
and then
I didn't.
like
I
that.
don't know why.
That's a later question, you're not there yet.
Whatever, you see what you did this year?
Yeah.
You need to answer numbers 2 through 4.
Oh, you want me to? You talk about a later question on this.
Yes.
Okay, I was gonna say.
I need y'all to go.
It helps
I need
my
y'all to go.
brain. Okay.
So you did
5
I'm trying to
over
use
2.
my.
Yeah, I'm trying to.
Probability.
No, 2 on the bottom. Because you want 2 correct.
Hold on, your formula is right here, right?
Yeah.
Why don't you start with your combination?
What are you talking about?
This is combination.
What's going on?
said this was.
And also, what's our probability of success?
I'm getting nervous because people are watching
Not
me.
0.2.
Well, for us it was, because you got
So
one
is it
five.
5 trials?
No.
No, that's
5
not
trials.
it.
So it's 5.
What's
Oh,
the
it's
probability if you get an answer?
5.
Right. How many answer choices are there? Alright guys, I need to pause us, I need us to be careful about this. Eyes and ears, look. Y'all stressing me out on this. Right here. Each question has how many answer choices? 4. How many here? Or so, what's the likelihood you guess and get this right?
25.
So 1 out of 4. What's the likelihood you guess this one right?
1 out of 4.
Okay, wait.
We know.
Woo!
Okay,
Probability of
what's going on?
success?
0.25.
Okay, thank you. 1/4 of 0.25, okay?
Wait, I got this.
What is the 5? That's the number of.
Okay, no, I just thought there was a 5th choice.
One thing I want to. Fair enough.
What's going on?
One thing I do want to point out really quickly, I need y'all to hear me on this. Hey, eyes and ears here. Normal distributions are defined by their mean and their standard deviation. Binomial distributions are defined by their number of trials and the probability of success. So if you are ever asked about this right here, Jade, I need us to get back on topic and focus on the actual stats that's going to be tested, and I need you helping your group.
Okay, I was confused.
Okay.
I was looking at that so long.
You ain't got to do all that. Jade's making life difficult.
I'm trying.
I know, but like we got calculators, bro. So, is this a binomial setting?
Yes.
Yes.
Why?
Because
You can either have a success or fail.
So you either get it right or you get it wrong. It's binary. How else do we know?
The set number of trials.
What's the second thing? Independent events. Woo! Guys, just go in the order of events. It makes your life easy. It's binary, success or failure. Get it right or wrong. Are they independent events?
Yes.
Does getting this one right affect your ability to get this one right?
No.
No. Is it a fixed number of trials?
Yes.
Yes, that's the 5. Is it the same probability of success every time?
Yes.
Okay, so is it a binomial?
Yes.
Yes. Now,
Yeah.
guys, I need y'all to pay attention because you got a formula sheet.
I get it.
What is the probability that x equals 2? Well, how many trials do we have?
5.
Choose
2.
2 times,
1/4.
so 1/4
Squared.
to the second, because we want 2 successes,
Multiply by 1 minus 1/4.
which is 3/4. And how many failures do we want?
3.
25.
I got that right. I thought it was more like.
Put all brains together.
Then notice I didn't say 1
I
minus.
mean, I know, but.
It's just
Zero.
1 minus the probability of success is the probability of failure.
It's like the rest of it.
Yeah.
That's what I
It's just the probability of failure and the
No, I'm
number
not
of
talking
failures.
about you. It's just because he said it earlier.
Yeah. I mean, that's what
We're
it
so small.
literally is.
I know.
Okay,
Okay.
so, by the way, how are we going to find that probability right there?
Oh my god, we're
Add that over.
No, I was saying, I'm just plugging into a calculator, guys. How many trials?
5.
Probability of success.
1/4.
How many values?
2.
There's my probability. Okay? Now, just remember, Jaden, you're not doing that on the AP exam. Don't waste that time. There's our probability. From here, though, I do want to point out, I need to do it for all those values, correct? I don't want to, same. Okay, so how about this? Braden, do you remember how I can get all those values in one fell swoop?
Binomial. CDF?
Now remember, CDF is going to add them all
Oh,
together,
you just
right?
don't like put the number of,
Oh, yeah, you
values,
don't put the X value, it's
values.
optional, yeah.
Yeah.
There we go. 0, 1, 2, 3, and then you can
4,
see
5.
the rest. Yep.
Wait, what's the difference?
I wish they did it like
So
by-
Oh my God.
PDF is a probability density function. It just gives you the probability of that individual value.
Oh, so
A
if you take off
CDF adds up those probabilities for you.
two, so you take off 2 and it gives you the probability for all of these?
6, 5.
Yes, if you put that 2 in there, it just gives you the probability of getting 2. Notice that's exactly, it's 0 successes, 1 success, 2 successes. It
So if
matches.
I plug in everything but 2, it'll give you from 0 to 5.
It'll give you each of those individuals, yes.
Okay, thank you.
You should be clicking A.
Oh, I know what I need to do. Never mind, I got it.
Okay.
I put 1 instead of
That'll do it for sure. Hey, where's your, you were just copying me down from what I
1.
had.
Starting to make sense.
I did not want to put it
Oh my gosh, my numbers. Okay.
Now,
0, 1,
0, 1,
4, 6. Yep, numbers.
in. Yay.
okay? Now, here's what I need you to do. I need you to find the mean, and I need you to find the standard deviation of the number of correct if we're guessing.
Here we go.
He's gonna show us from KD shortcut.
No, I'm not.
Well, can you just plug it into the table? and
Thank
do
you.
all that?
You need to put it in listen
I'm trying to
spreadsheets.
click on my perspective.
Yay.
So, put these values
Is
into
that
your
not
listen
right?
spreadsheets, calculate the mean and the standard deviation.
Okay, so show us the shortcut. 30 seconds.
Dude, I got 0.000.
Right here, guys. Put those values in. Let's go.
Oh my gosh.
Put in your listen spreadsheets. Some of y'all need some practice with this.
2, 3.
And we still got one more thing to go over after we finish this lesson.
I hate this thing. I'm like,
Dang,
Oh,
that's
okay.
Nope.
I'm so chill.
You said 4 decimal places.
Typically we do
Delete.
4
Oh,
decimals.
no,
Yep.
no,
Delete the stuff.
That's perfectly fine. Yeah, 4 of those decimal places.
Oh, gosh.
I'm doing it right so far.
Yep. 1, 2, 3, 4, 5. Yep.
Waiting for my
Put your
calculator to
probabilities in.
load is crazy.
Make sure you label.
396.
Okay.
0.26.
So this is,
If I put 3955 versus
just
395, it's the same thing.
Just do 3
7
to 4
will say
decimal
capital.
places.
Okay, what about the last one?
What do you mean?
Yeah.
Just go ahead and type it all in.
Okay. 'cause
I will
mine
say
stops
that,
at
if you type it all in, it's not a bad thing.
It doesn't change the numbers.
It'll change it a little bit, but that's okay on a P exam.
Okay.
It doesn't have to be 100%.
Okay. That made me feel better.
Why are they always screaming outside?
Thank
I'm
you. I be
so
thinking-
proud of them.
I'm
Yeah, it's part of the JROTC case.
It's always when we do the DUIs.
It's not, I don't know what, who
so
it is, I
loud.
need to know, like, go to class. What do those teachers do?
They be like bloody words for
Who
me.
is,
Bloody
what
words.
supervisor is that?
What would you find?
Ex-mean.
And it's like every day.
Oh.
Tennis kids are out there.
Yeah, but.
Yeah, that's not who we hear.
Yeah.
I'm really feeling that the window.
Oh, it's
I
a
have to
magic
like Garner
folders.
somebody.
I bet you.
Garner one of them, Mr. Kenny.
Mm.
Cause we used to go out there.
These are like their brain breaks.
No, it's not very very.
What the heck?
Hey,
is a
guys.
brain break?
Have you finished calculating your mean and standard deviation?
Almost.
Is that a 977?
000977.
I think I did
Oh,
this
it's
wrong.
that calculation.
Wait, why am I typing in the thing? Don't do that.
Six. That's where I'm
So those are the
I just
values you should have gotten.
1.25.
And then you do one variable statistic?
Custom context.
Oh my god.
One variable statistics. It's only
I hate
one random
interpreting.
variable. And then
Let me just at least
your
write it down.
variable you did is correct. And then we do a frequency list when we're doing probabilities.
I'm gonna custom.
Nope.
Is
Yeah,
the
change your
frequency list
frequency list.
correct, or?
It's the probability of being
What is
correct.
riffing?
You, or you overstand.
Correct.
You know that movement. You did it.
My arthritis should never.
Is correct the frequency?
Arthritis?
Oh,
You did it.
Will be.
I'm always like this.
I can't even do a
Yeah, 'cause you
probability
skipped
more, dude. It's so
zero.
sad.
And
That
then
is so
probability.
sad.
Can you cover it?
Not anymore.
Well, I don't think I could either, just because I'm like.
No, that is right. That's
I don't think I've ever been able
That
to
was
do
the probability.
Yeah, I used to be able to put both guys behind my head. And my brother would keep.
Hey, did y'all finish doing these
Probably why you
calculations?
have
Trying my
arthritis.
best.
Yes.
I don't know, check it.
Do a parallel.
Don't forget, cause I thought this was here.
That's the
Oh
variable.
my god, it didn't show
The
my
frequency list is your probabilities. All right, really quickly, just because I was looking through the textbook last night, or 2 nights ago, one of the two things, and I know we've been saying in the long run, and I like that language a lot for probability,
Oh, boy.
but the textbook and mathematic both agreed that when we are talking about mean and expected value, go ahead and say in many selections or in many trials or in there's not much of one. I don't think there's a lot, but one, to me, if both sources are agreeing using that language, then I would go with that language. Two, I think that the idea is kind of that you are looking at repeated sampling.
Isn't that what
And
the
you-
law is?
Yes, but after, when you say after many trials, it's much more clear that you're doing
It's
repeated
more
sampling.
direct.
Right.
Okay.
That's what I would say. And Jaden, I did think about it. The reason why you have to say after many trials or in the long run
That is not.
is because each of those probabilities in that probability distribution are only in the long run. So it only works if you are doing repeated sampling. Does that answer that question you had the other day? Okay. So we have that mean, we have that standard deviation. Everybody got those values? Any questions? Okay, Jaden, what were you saying a little bit ago though?
Listen.
I don't know. What was I saying?
Bloody got me paper.
You were saying something about he's gonna show
No,
us
I'm having to
something.
show you.
He's gonna show us the shortcut in 10 minutes.
I
Oh,
wouldn't expect it.
Would that be right? I can't tell if he's
I'm saying
smiling.
with this one.
Is he smiling?
If you
I
were to
got
go
8, 9,
into
and
the
not
depths
8,
of my
8,
mind.
7, 8.
Oh, bro.
If I open your Bible, it is in there.
Yeah.
Okay. So, I'm gonna go to the overview for the course guide. I'm gonna pull up the formula sheet.
Thank you. It is.
Hey, what type of distribution are we dealing with?
I know.
We're doing binomial right now. Does anyone see anything that might have made my job a little bit easier?
I know you're great. You didn't even take this.
Say again.
Oh, that was.
So we got our binomial here, and what's this? Oh, there's our mean. And this is our standard deviation. So the mean number of correct answers, what's that N stand for?
Number of trials.
Number of trials. What's that P? Probability of success, so 1/4. So what's that going to be? 5/4 or 1.25? Hey, what did we get in the calculator again? Yeah, but what did it say? 1.2487 for the mean?
Is it rounding?
Why do you think? Yeah, it's probably rounding error because we didn't go all the decimal places earlier, did we? No, so that might be it. Okay. So the standard deviation formula is the square root of what's in?
Number of trials.
Yeah, but what is that?
Mean?
5. What's probability of success?
Just have
And what's the 1 minus P?
Failure.
So 3/4. Alright, let's type that into a calculator.
I don't wanna hear it. I don't wanna hear it. You're taking the good class.
Hey guys, are you locked in and paying attention to these things?
I'm paying attention.
Locked in.
I'm paying.
So square root of 5 times 1/4 times 3/4 comes out to be 0.9682. What do we get in the calculator?
.968.
9674. Yeah, why do you think those are a little bit different?
Rounding error.
It's just rounding errors. So, if we have a binomial distribution, and we recognize that it's binomial, instead of doing all that work, there's my mean, and there's my standard deviation. So you have to recognize when you have a binomial or not. That could have made our lives much easier. And honestly, that makes sense, guys. If you have a 1/4 chance of getting the answer right, don't you just multiply it by however many that you're doing to get the average number? One thing also to remember is this: a lot of students on discrete random variables try to, or ignore the decimal. Don't do that. Because on average, or after, how would I interpret that 1.25?
Typical number of
So after many
trials.
but what would that context of this be?
expected number of answers right is 1.25.
Close, yes, but you're skipping one thing. After many what?
Trials.
But what would the trials be in this context?
The
Quizzes.
average.
Pop quiz.
The average number of
Questions?
answers correct on the pop
Answers?
quiz.
How about
Two.
after many 5-question quizzes, right? Because that was the whole context, 5-question quiz. So after many 5-question quizzes, we expect to get, so a typical number of what?
1.25.
So 1.25 questions correct. We expect to get 1.25 questions correct. But typically, we're going to differ from that value by how much? 967. Okay, so you have to be able to recognize binomial, you have to be able to recognize, or then use those formulas. So quickly, we gotta write this stuff down. There we go. So, calculate and interpret the mean of the distribution. So, make a note to yourself. Used lists and spreadsheets once. But the mean of x is just n times p for binomial.
Mr. Can you go to left real quick so I can just see?
No.
Alright.
Equals 5 times 1/4, or 1.25 correct. So after many 5-question quizzes,
Why can't you just say trials? You have to be like supposed
because I'm trying to put the what?
to.
Context.
So like,
Gotta have context. After many 5-question quizzes,
No context.
we expect to get
I mean, it emphasizes the many.
1.25 correct on
If you add the
average.
comma is.
All right. After that, calculate and interpret the standard deviation. So same thing, right? But How are we gonna calculate the standard deviation of that random variable?
Mean.
Square root of n times, nice, I like that language,
1 minus b.
which is the probability of
Failure.
failure. So you can memorize just the symbols, or you can remember what they actually mean. The number of trials times the probability of success times probability of failure, which is the square root of 5 times 1/4 times 3/4, 0.968? Am I remembering that correctly?
Yeah.
968 what? 2, okay. So, interpreting that, how would I interpret that? There's a few different ways. Typically,
It will differ from.
what differs?
The number of questions, right?
The number of questions correct,
Will
or right, either one.
will differ from the mean by 0.9682 standard deviation.
From the mean, not,
Not by standard deviation.
yeah, not by standard deviations. This is the standard deviation.
I don't-
Just by 0.9682 what? Questions.
Oh, yeah, yeah, yeah.
Okay, I'm going to quickly talk about number 7 to answer some of the lingering questions y'all had before. So, in number 7 it says, what's the probability of getting at most 3 correct? So, what's the probability notation I could use for number 7? Probability that x is
less than or equal to.
less than or equal to 3.
Is that binomial CDF?
So this would be a binomial CDF, and that's what I'd use in the calculator, but I would write out a couple of things first. And so look at your formula. So what is the lowest value that I could get correct? 0. So that would be, what's the n going to be?
5 choose 0.
5 choose 0 times
1/4.
1/4 to the,
0.
because it would be 0 successes, times
3/4.
to the,
Okay.
right? Probability of success to the number of successes, probability of failure to the number of failures, plus
5/1.
5 choose 1, plus
Dot.
Put it in twice and move on with your life. Normal CDF now. For real, calculators, normal CDF, I don't know, it's off the top of my head.
I have a question.
Go for it.
Where it says typically the number of questions, right, differs from the blank by.
Differs from the mean by.
Okay, thank you.
Thought I put that there, maybe I forgot it.
Braille was thinking faster.
Yeah. Well, because I still gotta get the next little thing out to y'all and go over it.
Does it matter that my numbers are so low? Like I have 9.9681 instead of 9.9682.
Lower bound is 0.
Well, that's from the calculator, right?
What are you talking about?
Yeah. That's because we got slightly different numbers.
And that's fine.
Yeah. So you did base it off of this.
No, I based it on yours. On the board.
Oh, then that's just rounding difference.
Okay. Thank you.
Mm-hmm.
Spacing out.
Okay. All right.
I clicked something, I don't know.
So what is that probability? I assume someone has put it in the calculator by now?
0.984375.
Okay. And you could have gone to 4 decimal places, but going more is perfectly fine. Okay. And then, so the last one, I'm not going to go over right now, but the probability that x is greater than or equal to 3. I guess I can go ahead and tell you because I do have it written down here. Comes out to be 0.104.
Cause she wrote that.
All right. So let's do some notes on the back. Say again, Lana. So I would again here I would plug it, write down the formula. I would plug things in, but then I would move on with my life. So here's what I want to do. Quick notes, and then we got to talk about the geometric still. It'll be the last thing that is on your demonstrate understanding tomorrow. I know, but we got the end of the semester, or 9 weeks coming up on us. So, using technology, which we already kind of hit on this, what I will point out is we're going to use binomial PDF when we are looking at what?
Probability equal to.
Say again.
The
So probability
That's
that
equal to.
probability that x is
Is
equal
equal
to
to.
a value,
Yeah.
right? So remember, PDF, probability density function, is for a single value. Binomial CDF is when we are looking at,
Greater than.
Greater than or less
equal
than
to,
or equal
Or
to.
less than, or less than or equal to.
Yeah.
That's what I was actually doing.
sorry. Well, I'm glad we got an answer.
So on that top one, you just put x is greater than but I thought equal to. Would that technically still go under a CDF or no?
It would still be a CDF.
Okay.
But I did one greater than and one less than or equal to. It is important to remember, if I were in this context, this problem, if I were to say greater than 3, would that be equal to probability that x is greater than or equal to 3?
No.
No, right? And so we need to remember when it's discrete, whether it equals 3 or not changes things, right? This would be the same as the probability that x is greater than or equal to 4, actually. These would be equal, right? Because 4 is greater than 3. So be careful about those differences. You can write it multiple ways, but be mindful of those differences. Yeah. So the second piece of this is mean and standard deviation. And this is where I was looking at it and I was like, yeah, we'll probably just stick with this language. Luke Wilcox, who founded Stats Medic, is probably one of the best stats teachers, top 5 that I've met for sure.
Who's number 1?
Josh Tabor, who wrote our book, is pretty fantastic.
You've met
Wrote
him.
it, the author.
Yeah.
Did you get a signed book?
I did not.
Get a sign.
I didn't use his book back then, actually.
Who's number 2?
Wait, when is the textbook
I
coming?
mean, it might be Luke
Never.
Wilcox. I actually asked
Never.
Mr. Hinton, he said, I hope that it's here over spring break.
Allegedly.
He wants people
I
to
just
point
wanted
that
to
out.
know.
I know, it's already halfway through the class.
That's just for like people next year. By
That's exactly halfway through the class. That was crazy.
Many.
I deserve money.
more than halfway through the class, because seniors end early.
Can we like not pay this class fee?
Yeah.
Exactly, I deserve
Well,
financial
yeah.
compensation.
It's not like I get any of that money, I don't know.
Because I haven't put at
Where's the money
disadvantage
going?
compared
To
to
the
other students.
exams. That's the original.
Well,
No, 'cause
no,
we
you also have
already
to pay
pay
a
in the
fee to
exam
be
fee.
in the class.
You have to pay to be in the class?
Yeah.
Yes.
It's like
God.
You
25
think you got
bucks.
here for free?
No, I thought it was paid for.
Like all honor
It's
classes.
for the
you have to pay
labs and
extra.
stuff.
What
What
lab?
lab?
Mr. Kenny, we did no type of lab besides those Starbursts. They came out of your water.
Excuse
So I don't know why they trying to play
Blocked.
you.
Blocked.
They trying to play you, Mr. Kenny, because that came out of your water.
To pay off his debt to the
It
teens
did.
files.
Hey guys, y'all need to get this down.
I mean,
You're
I get it if it like
nervous.
pays the teachers, but like it doesn't.
Maybe it's because
like
of the paper usage and ink. It goes for ink costs.
Okay,
He
Right
has to
there.
pay for that too.
Honestly,
guys, I'm moving on because we gotta talk about the next thing in the next minute. Start talking about the next one in the next minute. So if you need to take a picture, you take that picture, but we gotta go. There is a little bit more with binomial distributions that we will look at, thank you, tomorrow. However, we don't need it yet. You may want to do the check your understanding. In fact, I would recommend that we can go over it before the demonstrate understanding tomorrow. So, what we're about to talk about is something called a geometric distribution and geometric random variable.
Wait, I'm
So-
confused. What am I supposed to be writing?
This,
Oh, wow.
After many, okay, it reminds me of the movie The Other Thing.
this is
Everything.
how
on the
to
right.
interpret.
So everything on the right, you right.
If you're asked to interpret, yes.
Okay.
Okay. This is actually 6.8. We're skipping 6.7 because we'll get to that later, but I need to talk about geometric. So let's say he flipped, so the senior talent show is scheduled to take place this afternoon, and who was it? Michael Senatore is in stats class practicing his act, bottle flipping. He tells his friends, probability of successfully landing the water bottle right side up is 20%, which, man, sucks to suck. Assuming that each water bottle flip is independent, if he flips the bottle 10 times, how many do you expect to land right side up? How would I find that?
2.
How many?
2. but
2. Why do you
the-
say 2?
0.2 times 10,
So why would 0.2 times 10 make sense here?
because that's probability multiplied by
Number of
number of
trials.
times.
Oh, so what are you implying that we have right here? If you're saying the probability times the number of trials, is this a binomial situation?
Yes.
Is it binary?
Yes.
Are they independent trials?
Yes.
Is it a fixed number of trials?
Yes.
Is it the same probability of success?
Yes.
Notice I checked my bins, right? It's binomial. So the mean of x is just 10 times 0.2, or we expect to see 2 land right side up. So, binomial. Next part. What is the probability that he makes exactly 2 flips? How would I find that? How would I write that? Or start that?
10, choose 2.
Well, I'm going to start with something else first.
Probability
Probability that
x
X
equals
x equals 2.
And then 10.
10 choose 2.
0.2 to the 2. Times 0.8 to the 8.
And then I'm not doing that by hand. I'm going to what in my calculator?
Distribution.
Which distribution?
Oh.
Oh my god.
Binomial
PDF.
PDF. It's a single value, so go to binomial PDF. 10 choose, and then we need that 2. And I want you to go ahead and do this while you're there. Go ahead and do the calculations for the next 2. Do you notice probability that he makes less than 2 flips? What would that be? X is less than 2. Probability that he makes 2 or more.
Probability of x is greater than or equal to 2.
All right, I need you to find those probabilities quickly.
You got the first one?
Equal to.
Yeah.
Did you get this?
Probability of makes
Yeah.
less than 2 flips.
What can I ask? Did you get this ever since you know?
Me?
No.
Oh.
You know, just the senior thing. Yeah, I got it. You excited? Yeah.
Upper bound of 2.
Probability of
Oh wait, yeah, upper
I
bound
paid
was
online and I asked her to ship it to my address. Wait, so it was supposed to come?
Wait, no.
Oh, no, not the sweatshirt, like the actual thing. Yeah, because I did it like all online.
Hey, have you finished,
I am currently doing it. I can talk into it.
can you do it efficiently?
Yes, actually, I am on the binomial CDF right now.
10.
I'm confused as to upper and lower bound.
Huh?
That's not true.
Alright.
Unlike CDF, just upper and lower bound.
Wow.
So,
So,
yes, sorry.
For, it says less
So I
than
can see
2.
the,
I put
well, the lower bound would be 0, right? That's the least I need.
Well, if it's less than 2, it could
And
be,
upper bound.
what could x equal?
1.99.
2 or less.
No, it cannot equal 2 or less, it's only less than 2.
I mean, equal to 2 or, you know,
Like
the
how
second one, right there.
short will calculate
What?
way.
If x
Equal to
can
or
be,
less than?
if x is less than 2, what can x equal?
These numbers are using count.
1.
Or,
0.
right,
2,000. You had to use
so, and so Dan, I heard you asking about this. Notice, if it's less than 2, it could be this or this, what's lower?
0.
And what's the upper?
One.
Oh.
That's it.
So, quit.
But if you try this.
I put this.
No. Are you trying to do the, you trying to do that one?
Yeah.
Oh, exactly 2 flips? Yes, you put 2.
I mean, for the,
Get
if
out
I
of
were
my
to.
head.
But
just because
Yes.
this one?
Because you
You
know
went
the
to
references.
first off, you need to read, that says probability,
You know what I mean?
0.2.
Because
You want exactly
you
2
can't get 1.99,
successes.
right? You can only get 0 and 1.
Now,
But
the lesson you really
okay
do
with that.
I'll just do the CDF thing and.
is,
So was it?
it's still 10 trials, it's a 0.2% chance of success, and you could have 0 successes or 1 success.
Oh, okay, okay, that makes
Right.
sense. I get that.
So 0.37581, is that right?
Yes, sir.
Alright, now, I will point this out really quickly. For this last one, what would my lower bound be?
2.
2, what would my upper bound be? 10. And I could go through all that again, but is there an easier way that I could find out what the probability of x is greater than or equal to 2?
1 minus the probability
Nice.
of less than 2.
So,
Whoa.
you can do 2 up to 10, or you can just do this,
I mean,
which is 0.62419, I think. Check me on that.
Wait, yes.
because everything adds up to 1. Every class.
Oh, frick, we gotta go.
We started.
You got like 5
Okay.
minutes to you.
Yeah, and which means we're about to move. So, after the first 10 flips,
Let's
Michael
go
wants to do
upstairs.
more, but his teacher is getting annoyed with all the noise and tells him to stop flipping once the bottle lands right side up. So,
It's not bad.
what is the probability that he lands it right side up on the first try?
What?
0.2.
0.2.
Okay.
Okay? What is the probability that he fails on the first try and lands it on the second?
0.8.
0.8 times
Wait.
2, so 0.6.
So the probability that he fails on the first one is 0.8, and then has a success on the second one is 0.2, right?
0.16.
So 0. What?
0.6.
16?
Yeah, 16.
16. That is not what I heard. I heard 6, 8. I don't know.
I also
Okay,
had,
6, 8.
I thought we was on these.
So success, failure, then success. Number 7, probability that he fails the first 2. So that would be fail, fail, then what?
Success.
So how am I going to write that probability?
0.8
Squared.
0.8.
0.2.
Okay. And so, the probability that x is equal to 3 is 0.8 squared times 0.2. Whatever that is.
128.
Okay? So what if it's going to be on the 4th try that he has a success?
Oh my god.
0.8 to the third.
It's going to be 0.8 to the what?
The third power.
0.1.
Times 0.2.
0.2.
Okay? So, from there, this is what we will call, and so let's go ahead and fill this in. What was it? It was 0.2, 0.16, what was next?
0.128.
Then next,
0.1024.
was it 0.0124?
1024. No, 1024.
1024?
Yeah.
Does anyone know what we would call this if we were talking about a sequence or?
Multiply.
Ah.
Geometric.
This is an exponential function
Oh my
if
gosh!
it's, hold up, if it's continuous. If it's not continuous, if it's a sequence, we call it a geometric
Cheers.
sequence.
I was
Okay?
so close.
And because it's a geometric sequence, we call it a geometric distribution.
Wow.
Yeah, wild.
It's almost like
We're speedrunning.
It's almost like those names mean something. Okay, find the probability that he lands it on the 10th try. How would I find the probability that he lands it on the 10th try?
9 or 0.8.
0.8 to the
9.
9th times
0.2.
0.2. So, how are we figuring this out? It is the probability that x is equal to x is what? What is this probability every
For
time?
what?
Probability of
Failure.
not success.
failure.
That's failure. Because remember, that means we're going to have that many failures, right? And then how am I going to figure out how many failures it is?
Number of trials minus number of successes.
X minus 1, right? Because the very last one is going to be my success. Okay, so I don't have enough time for the full reveal. Does anyone see anything useful on this
It's
formula
right
sheet?
on there, it's on the paper.
Holy
Wow.
crap, it's the very last discrete random variable. So a geometric distribution, I do need to point this out because I'm not gonna, I'll actually upload it as a video, but how do we know when we have a geometric?
It's exponential to a point.
Yes, but I will point this out. We are looking for the
Until
first, how do we know when to stop?
success.
Right, we're looking for the first
Until
success.
success.
We don't have bins anymore, we have bits. B stands for binary,
Independent.
independent. We have trials until
Success.
a success. And then do we still have the same probability every time? Yes. How are we going to find the mean for that geometric?
Wait, what?
1 over probability.
And there's my standard
Why did I write
deviation.
it Z?
The biggest thing, guys, is being able to recognize those binomial versus geometric, because once you do, you got a formula. By the way, do you think there might be a geometric PDF and CDF in that calculator?
Probably.
Heck yeah, there is. Okay. Here's 2 more probability free response questions. Notice 2011 number 3, and then on the back is 2018 number 3. I don't know if you've noticed this, but number 3 on the AP exam is almost always the probability question. Number 3 is almost always the probability question.
How many free responses do we have in tests?
This upcoming test,
No, like.
on the
AP
total test, there are 5 standard ones, and then there's one that's called an investigative task that's a little bit more involved. We'll start looking at that later.
Okay, and then how many multiple choice are there?
40. And
That is
Take
short.
one in his
That is
Exactly, I'm thinking.
you say that, think about the
The
multiple
exam?
choice questions that are in this class. They're very similar.
Yeah,
It's
so
2
you
and a
have to work
quarter.
them out.
Huh?
So yeah, so you have to work them out, but like overall, like
Yeah.
questions.
It's not that many questions, but
At
it's
least
90 minutes for
false
each section.
statements.
Hey, are either of y'all gonna see, any of y'all gonna see Serena and or Peter?
Maybe I could stop by at the gym.
I mean,
Can you do that?
Yeah.
Vander.
Okay. There's that. So, again, DYU is tomorrow. I know tonight I had to leave, but DYU is tomorrow.